All right, so today we're going to deep dive into something that sounds like it's straight out of sci-fi, you know, quantum computing.
Yeah.
It's this tech that has the potential to, like, revolutionize everything.
Solely.
From medicine to, like, materials.
Yeah.
But it's also a little bit mind-bending to wrap your head around.
Oh, for sure.
Well, today we're going to try to break down a recent news piece from the U.S. Department of Energy.
Right.
And it's about this potential game changer, a new hybrid approach to quantum computing that could make it a lot more, like, practical and usable.
Exciting stuff.
Yeah, and don't worry, we're going to make sure that even non-physicists like myself can actually understand what's going on.
I think we can do that.
All right, so before we get into the specifics of this hybrid approach, let's just get like a really super fast,
Sure.
jargon-free explanation of what makes quantum computers different from the ones that we use every single day.
Gotcha. So basically, the building blocks are different. Everyday computers use bits, which are like tiny switches that can be either on or off, 1 or 0.
Yep.
Quantum computers use qubits, which are way more flexible. You can kind of imagine like a coin spinning in the air.
Okay.
It's not heads or tails until it lands. It's kind of both at the same time. Qubits can be in this blurry, both at once state. It's called superposition. And it allows them to do a lot of calculations in parallel, like tackling tons of possibilities all at the same time. That's why these quantum computers have the potential to solve problems that would take our best supercomputers, millions of years to figure out.
Okay, so it's like having a million computers
Yeah.
all working on the same problem at the exact same time.
Exactly.
That's pretty wild.
It is pretty wild.
But, our source article, it mentions this bottleneck, this thing called quantum gates.
Yeah.
So what are those and why are they holding us back?
Okay, so quantum gates are like instructions that we give to the qubits. They tell them how to manipulate information. The catch is that even simple algorithms need to be broken down into like a massive number of these gates. It's kind of like writing a super complicated recipe for like a super simple dish. And this makes quantum programs really, really long and super sensitive to errors.
Errors? What kind of errors are we talking about?
Well, the quantum world is incredibly delicate. Qubits are easily disturbed by like their surroundings. Think of it as trying to write something on a piece of paper while somebody's shaking the table. It's kind of like that. This noise limits how long quantum computers can run accurately and do those big, complex calculations we were talking about.
So it's not just about building these powerful quantum computers, but also about finding ways to make them more reliable.
Exactly.
And less prone to those errors.
For sure.
Which brings us to this exciting hybrid approach.
Yeah, it's really cool.
Tell me about that.
Yeah, so this new hybrid approach is about finding clever workarounds. Like, imagine you're trying to navigate a really complicated maze. The traditional approach with these quantum gates, it's like following each and every turn meticulously.
Right.
Which takes forever and increases your chances of getting lost or making errors.
Right.
The hybrid approach, it's like finding shortcuts through the maze.
I like that.
It lets the physical system do some of the computational work instead of forcing everything through those complicated gates.
So we're kind of working with the quirks of the quantum world instead of trying to control every single tiny step.
Exactly. You got it.
Okay.
And what's really cool is that this might let us use the current quantum computers, the kind of messy ones.
The ones that we have right now?
The ones we have right now for much more advanced calculations.
Now, the article mentions that the researchers use something called Grover's algorithm to test this hybrid approach.
Yeah.
What makes this algorithm so special, and why should we care?
Well, Grover's algorithm is amazing at searching through huge data sets. It's like finding a specific grain of sand on an entire beach.
Wow.
It's really relevant for things like drug discovery, financial modeling, anything where you have to go through tons and tons of data.
Okay.
And this hybrid approach, it made this algorithm even more powerful.
Okay, how so?
Well, it simplified a really crucial part of the algorithm called the oracle.
Okay.
Which basically tells you if you found the right answer. Imagine a sniffer dog that can instantly tell if you found that specific molecule you're looking for in like a giant library of chemicals. Usually setting this up in a quantum computer requires a ton of gates.
A ton of gates.
With this hybrid method, they did it with just a single spin.
Wow.
Interacting with the rest of the qubits.
So we went from this massive, complex setup to something super streamlined.
Exactly. They were able to kind of make the oracle part of the quantum system itself. cutting out a lot of complexity and potential errors.
And on top of all of that, this method is what they call topologically protected,
Yeah.
meaning it's really resistant to those errors that we were talking. It's like the information is encoded in a way that's like almost immune to the noise of the quantum world.
It's like if you wrote something down and no matter how much you spilled coffee on it or crumpled up the paper, it would still be perfectly readable.
Okay, that's a great analogy. So before we get too carried away with all the excitement, let's bring it back down to earth for just a moment.
Sure.
What does this all mean for, everyday folks like us?
Right.
Is this a sign that practical quantum computing is closer than we think?
It's definitely a huge step in the right direction. This hybrid approach could make these quantum algorithms a lot more efficient and less prone to errors.
Right.
Even with those imperfect quantum computers we have right now.
The ones that we have today.
Exactly. While it's still early, we could see real-world applications sooner than we thought.
That's exciting. So which fields do you think are going to benefit first from these advancements?
It's hard to say for sure, but things like drug development, materials science, and cryptography are all really good candidates. Imagine being able to design new medicines super fast and super accurately, or being able to make materials with properties we haven't even dreamed of, or creating encryption that's basically unbreakable.
That is mind-boggling. It really is.
It is. It really is.
To think about the possibilities.
Yeah.
So it sounds like this hybrid approach is not just a technical feat,
Right.
but a potential gateway to this whole new era of technological advancement.
Yeah, that's a great way to put it.
This really is fascinating stuff, and it kind of makes you wonder, what problem would you want to solve if you had access to a powerful quantum computer? It's something for our listeners to kind of ponder as we continue this deep dive into the exciting world of quantum computing.
Absolutely.
It really is an exciting world.
It is. Yeah, it really is a question that gets the gears turning.
One thing that really stuck with me from the article was this idea of topological protection. It almost sounds like a superpower itself. Can you break down what that means in a way that even I can understand? And why is it so important for quantum computing?
Okay, so topological protection, it's like a shield that safeguards information from the noise and errors that we were talking about that plague these quantum computers.
Yeah.
It comes from the unique way that information is actually encoded in certain quantum systems.
So it's like a built-in defense mechanism against that fragility of the quantum world.
Exactly. Imagine like a rope.
Okay.
Where the information is encoded not in the individual strands, but the way the rope is braided. No matter how much you twist, bend, or tug on that rope, that braided pattern.
Right.
And therefore the information, it stays intact.
Okay.
That's really similar to how topological protection works. It encodes information in a way that's really robust and resistant to disruptions.
Wow, that's a much clearer image than trying to picture knots in my head.
Yeah.
So with topological protection, even if there are imperfections in the physical system or interference from the environment, the computation, it stays safe and sound.
That's the idea. It's a game changer for quantum computing because it means we can perform these complex calculations with much higher accuracy, even with these kind of noisy quantum computers we have today.
It seems like this hybrid approach is tackling the challenges of quantum computing from all angles.
Yeah.
It's simplifying the algorithms, it's taking advantage of those natural quantum interactions.
Right.
And providing this incredible topological protection. It's like hitting a quantum home run.
Yeah, it's very elegant and multifaceted.
Yeah.
And it speaks volumes about the creativity of these researchers in this field.
Okay, so amidst all of this excitement, we should probably acknowledge that quantum computing is still a relatively young field.
Absolutely. We're still in the early stages of understanding its full potential.
And like with any new technology, there are bound to be bumps in the road.
Of course, building and scaling these quantum computers is incredibly complex.
Yeah.
We're still figuring out the best ways to control and manipulate these delicate quantum systems. It's kind of like trying to build a house of cards in a hurricane.
Yeah, a very, very delicate house of cards.
Very delicate.
But despite the challenges, the progress that we're seeing in quantum computing is undeniable.
It's moving at an incredible pace.
It is. It really is exciting to see.
Yeah, it's a really exciting time to watch this field evolve.
I agree. And with these kinds of breakthroughs, who knows what the future holds? Maybe one day, quantum computers will be just as common as our laptops or smartphones.
Maybe even more integrated into our lives than we can imagine right now.
Yeah.
Quantum computing has the potential to revolutionize not only our technology, but our fundamental understanding of the universe itself.
Now, that's a thought-provoking statement.
Quantum mechanics, the theory that underpins all of this, is one of the most profound and mind-bending concepts in physics.
It's definitely challenged the way that I view reality.
For sure.
That it's also one of the most successful theories that we have,
Yeah.
It explains phenomena that classical physics simply cannot account for.
Exactly. And as we build more powerful and more accessible quantum computers, we get the ability to probe this quantum world with even greater precision. Who knows what secrets we'll find, what mysteries will unravel.
This deep dive has certainly opened my eyes to the incredible potential of quantum computing and the brilliance of the minds that are working on it.
It's been a pleasure exploring this topic with you.
And with our listeners as well. But before we wrap things up, I have one final question for you.
Okay.
Given all the challenges and the uncertainties that lie ahead, what makes you so optimistic about the future of quantum computing? What gives you hope that we'll one day unlock its full potential?
That's a great question. I think my optimism stems from the sheer dedication and ingenuity of the people that work in this field.
Yeah.
Scientists, engineers, mathematicians, all pushing the boundaries of human knowledge, collaborating across borders and disciplines. It's really inspiring.
It's like a global community coming together to try and crack the code of the quantum world.
Precisely. And that shared passion, that drive to explore the unknown, that's what fuels my belief that we'll overcome these challenges and usher in this new era of quantum innovation.
It's incredible to think about the possibilities. It's almost like we're standing on a precipice of a whole new scientific revolution.
And who knows, maybe one of our listeners today will be a part of it,
Yeah.
Maybe one of them will make the next groundbreaking discovery in quantum computing.
What a thought. We might have some future quantum pioneers listening right now.
I wouldn't be surprised at all. The future of quantum computing is bright, and it's full of opportunities for those who dare to dream big.
So well said. And on that note, I think it's time to wrap up this part of our deep dive.
Yeah, I agree. It's been a fascinating journey so far.
But before we go, I want to leave our listeners with one final thought to ponder. Imagine a world where quantum computers are readily available.
Okay.
A world where we can harness their power to solve some of humanity's biggest problems.
That's a tantalizing vision.
What would such a world even look like,
Uh-oh.
How would it change our lives, our societies, our understanding of the universe itself? These are questions worth contemplating, questions that invite us to envision a future shaped by this incredible power of quantum computing.
Excellent questions. I encourage our listeners to explore them further. We've only just scratched the surface of this topic today, but I hope this deep dive has ignited your curiosity and inspired you to learn more about this world of quantum computing.
And who knows, maybe you'll be the one to write the next chapter in this incredible story. The quantum realm is full of possibilities just waiting to be discovered.
Yeah, it really makes you think, doesn't it?
As we've been discussing this hybrid approach, it strikes me that it's not just about making quantum computers faster or more powerful. It's about making them more accessible too, right?
That's a really important point, yeah. One of the biggest hurdles to actually using quantum computing has been the complexity and cost of building and maintaining these things.
Right.
They require specialized equipment, super cold temperatures, and expertise that's not exactly easy to find.
It's not like you can just, order one on Amazon and set it up in your basement.
Right, exactly. Not yet, at least. Right now, access is pretty much limited to these big research institutions and companies with tons of money.
But this hybrid approach, by simplifying the algorithms and making them more robust, could potentially lower that barrier to entry, right?
Yeah, absolutely. If we can make quantum computing more efficient and less reliant on really expensive, error-prone hardware, it just opens up a whole new world of possibilities.
Right.
Imagine smaller research groups, startups, even just like individual innovators all having access to this tech.
It's almost like the early days of personal computing, when computers went from these room-sized machines to something that could fit on your desk.
Yep.
Like a whole new world of possibilities opened up then, and it feels like we're on the verge of something similar with quantum computing.
It's a good comparison. And just as personal computers revolutionize the way we work, communicate, and live, imagine the impact if quantum computing was just as accessible.
Yeah.
We could have entirely new industries emerge, problems we thought were impossible to solve being tackled, head on.
Right.
Breakthroughs in medicine, materials, AI, the possibilities are just mind-boggling.
What would those everyday applications look like? Would we have quantum-powered smartphones?
Hmm.
Would doctors be using these things to diagnose diseases
Yeah.
with incredible accuracy? Would we have, like, materials that are stronger, lighter, more efficient than anything we can even imagine?
It's a really cool thought. And, it's not just about solving those practical problems either.
Right.
Quantum computing also has the potential to really change our understanding of the universe itself.
We've been talking a lot about the practical applications, but it's important to remember that quantum computing is rooted in one of the most fundamental and mysterious theories in physics, quantum mechanics. It challenges our classical intuitions about how the world works, revealing a reality that's often counterintuitive and full of surprises.
Exactly. It's like we're looking through this new lens at the universe in a way we never have before. And as we build more powerful and more accessible quantum computers, we'll be able to explore this quantum world with greater precision, potentially unlocking secrets that have been hidden from us for centuries.
It's like having a key to this hidden door, this door that leads to a deeper understanding of reality itself.
It's a good analogy.
This whole journey from, the intricacies of quantum gates to this mind-blowing potential of this hybrid approach has really made me realize how important investing in quantum research and education is.
I totally agree. We need to support the next generation of quantum scientists, engineers, and entrepreneurs. They'll be the ones pushing this field forward. Asking the big questions, challenging those assumptions, and making those discoveries that will shape our future.
It's like we need to cultivate a culture of curiosity and exploration.
For sure.
One where people aren't afraid to venture into the unknown, to embrace the weirdness of the quantum world, and see its potential to transform our lives.
That's where the real breakthroughs happen, not by sticking with the familiar,
Right.
but by pushing the boundaries of what we know and what we think is possible.
This deep dive has been an incredible journey, from those nitty-gritty details of quantum gates to the world-changing potential of hybrid computing.
Yeah.
It's left me with a feeling of awe and excitement for what the future holds.
It's been a pleasure exploring this with you and our listeners. We've covered a lot, but hopefully we've left you with a sense of wonder and a thirst to learn more about the world of quantum computing.
It's a field full of challenges, but also full of promise.
Totally.
And who knows, maybe one of our listeners today will be the one to make the next quantum leap.
The quantum realm is waiting to be explored, and the possibilities are, as you said, quite literally limitless. So keep questioning, keep learning, and keep diving deep.
Beautifully put. And on that note, we'll wrap up this deep dive into the fascinating world of quantum computing. Until next time, farewell from the deep dive.